So every time I say let's get started, what I mean is I'm going to turn on the video for you guys so that the recording has started. Now, in today's class, and again, first Bernie and everybody else, okay, there is no penalty for making mistakes. Meaning, if I ask you guys a question, something that I'm doing on the board, something I want you guys to solve, give it a shot. Don't be afraid of making mistakes or anybody laughing at us, because making mistakes is the only way we learn things. So be brave and be open and ready to make mistakes. That's okay, perfectly fine. So what are we going to do today? So I have sent two topics for the day. One is practicing long polynomial divisions, and second thing is learning the concept or the formula for or learning the theorem called polynomial remainder theorem. So that will be the second step. So first thing we want to do is make sure that all of us, hey Deep. So first thing is we wanted to make sure that we are comfortable with long division of polynomials. What do I mean by that? Let's look at it. If I say, everybody can hear me okay, right?
Yeah.
Wonderful. So if I say dividing a long polynomial, what do I mean by polynomial? Everybody knows. I'm talking about an expression which has more than one term, right? So the 2x squared plus 4x minus 9 is a polynomial. We have 1, 2, 3 terms. If I'm talking about 6x cubed plus 5x plus 5x squared minus plus 7x plus 11. This is also a polynomial. We have 4 terms. Correct? Hi, Sarah. So what I'm saying here is, do we all know what do we mean by dividing polynomials? Meaning, if I have this polynomial, let's say, if somebody says divide that by x plus 2, do you guys know how to divide this? Or have you guys practiced that enough? Let me do a quick check. Okay. That's what Pandit is saying in the classroom. So let's get our hands dirty, right? Because the only way we all learn math is by doing math and making mistakes. Making mistakes is perfectly fine. So let's see, Neil also joined, and we have Vishal as well. So everybody be ready to see how do we do division of a polynomial by another expression. Let's say if I say divide 4x squared plus 2x minus 8 by x plus 1. Can you guys give it a shot? Try. See, everybody knows if I ask you to divide 15 by 3, easy peasy, nobody worries about it. If I say divide 171 by 15, that also you will be able to give it a try. We are going to the next level of calculation where we are trying to divide a polynomial by another expression or a polynomial. I mean, this also has 2 terms, so you'll say this is also a polynomial. So I'm saying, can you guys try dividing this by this and tell me what the answer would be? I'm not trying to put anybody on the spot. I'm just trying to get a sense of how comfortable are you guys dividing a polynomial by an expression. Let's give it a shot. Can I assume everybody is trying? Okay, wonderful. Yeah, 100 points for trying, okay? And why I'm emphasizing on doing this division, because that is what will be the base of dividing or learning that polynomial remainder theorem, okay? So, and that theorem is more like a magical thing, okay? So we'll look at what exactly that is and how does it help. So while you guys are trying, I'll just grab my water bottle. Yes, Prisha.
Sir, I got 4x minus 2 plus 10 over x plus 1.
Say it one more time.
4x minus 2 plus 10 over x plus 1.
Okay. Yes, Chris.
Sir, I got 4x minus 2 minus 6 over x plus 1.
Plus 4x minus 2 plus
Minus 6 over x plus 1.
Okay. All right. Anybody else who is still working on it need 30 more seconds, or you would want me to disregard whatever Prisha and Chris said and try doing it? Yes, Deep.
Yeah, I got 2 times 2x minus 2 times x plus 2 over x plus 1.
One more time. 2x minus 2. 2 times
Times x plus 2 over x plus 1.
I don't think I could hear you completely better. Say it one more time. Sorry.
Times x plus 2. Yeah, in parentheses, over x plus 1.
Okay. Okay. So now I have got all diverse options, okay? So that's where I keep on telling one of the most hated statement that I don't trust anybody. It's not that I don't trust any of you, I don't trust anybody when it comes to solving maths. I always believe in doing it myself. Hey, Rehan. So now all the answers we got, right? I mean, that is good and bad. I don't know which one is right, which one is not. So let's try doing it in the simplest possible way. I'm sure you guys would have learned all interesting techniques for doing it, but I'll do it like how a child would do. Okay. So this is the thing that we are trying to solve, or this is what we are trying to divide. We are trying to divide this by x plus 1. So you always go in this order, meaning you first try matching the maximum power. You try knocking it off. Then you go to the next one. Then try knocking it off. Then you try going next one, knocking it off. Meaning, what do you multiply with x to get a 4x squared? That is 4x. Okay. So let's multiply this whole thing by 4x. So if I multiply this by 4x, this becomes 4x like this. It becomes 4x squared plus 4x. So put 4x squared plus 4x. Okay. So stop me if I'm making anything look complicated. Okay. I've done a very simple thing. I did this now. Okay. So this gives me now regular division, like let's subtract this. So this gets these two knocked off. What we are left with is 2x minus 4x. That makes it minus 2x, and then you have 8 as a remainder. That comes down. I mean 8 is remaining, that comes down. So now again the same thing you will do. What do I do to knock off this guy? Meaning, what do I multiply this guy with to get a 2x? Obviously the answer is minus 2. So the first one will become minus 2x. So multiply this by minus 2. This becomes minus 2x minus 2. So I'm multiplying this whole thing by minus 2, right? So this gets me minus 2x minus 2. Now subtract this thing. So this becomes plus, this becomes plus. These two gets knocked off, and then you are left with minus 6 plus 2, that is minus 6. So now we cannot go beyond this because we have reached to the lowest possible power of x, which is the 0th power. So this eventually becomes a remainder, like any division you would do, right? So the answer that we got was, when you divided this whole thing by this, or this polynomial by this, you got this as your answer and this as your remainder. So then you will see my answer is 4x minus 2, this is your answer, and then you're left with this value minus 6, which you could not divide by this. So whoever got this answer was probably doing it the way I have done. Anything that I have done so far, is it not in line with how you had tried doing it? Anything that I missed versus where you believe you might have gone wrong? A question for everybody who tried solving this problem. No? Okay. So, a simpler question to you all. Did you guys understand what I did in the first place? Clear? Now, this was the base for us to start. Meaning, when I'm trying to divide a polynomial by another expression, we did that simple division that you guys have learned long time ago, and we just apply similar concepts to do this division. Now, the polynomial remainder theorem, which is more like a magical thing, okay, that says if you have a polynomial, let's say y equal to fx, which is something, let's say whatever it be, okay, I'm not putting it. If you have a polynomial y equal to fx, and there is an expression for that, I'm not calling it out. It says pick up any polynomial, and if you try dividing that by x minus a, okay, you will get a remainder which will be f of a. So, sounds cryptic? Simple. If you have any polynomial and you divide that by x minus a, you will get a remainder which will be equal to f of a. Now let's pick up something. Let's try solving it and see what sense it makes. Okay. Only thing you have to say, okay, you have a polynomial, you're dividing that by x minus a, and whatever is the a, function of a is what will be a remainder. Always, regardless whether you're talking about power 3 polynomial, power 8 polynomial, power 20 polynomial, doesn't matter. Let's look at it. Did you at least understand what is meant by polynomial remainder theorem? Right? I have polynomial, if you divide that polynomial by x minus a, the remainder will be equal to f of a. Now let's look at application of this whole thing. Let's pick up a simpler problem to solve. Okay? Let's say I have polynomial y, something like function of x, y equal to function of x, equal to, let's say, x squared plus 6x minus 18. I'm trying to divide that by x minus 3, let's say. What this polynomial remainder theorem says is, if you divide a polynomial by x minus a, this is your a, 3 is your a, then whatever answer you get, your remainder will be equal to function of 3. Now let's try doing that. Now, here we are trying to divide this guy by x minus 3. Okay? So let's see what that would be. X squared plus 6x minus 18. I'm trying to divide that by x minus 3. Now same thing, you will first try matching this power. So here if you multiply this by x, you will get x squared. So let's pick first one as x. So you multiply x by x minus 3. This becomes x squared minus 3x. Subtract this. This is knocked off. You are left with 6x plus 3x, 9x minus 18. Okay. Now, how will you divide this? Again, you will probably multiply this by 9 to knock off the x element, right? So, let's say plus 9. So, you are multiplying this whole thing by 9. This becomes 9x minus 27. Put 9x minus 27. gone. This becomes 27 plus and 18 minus, which is plus 9. So this is a remainder. Yeah. Let's see if this polynomial remainder theorem is trustworthy or not. This polynomial remainder theorem says if you have a polynomial, if you divide that by x minus 3, your remainder will be equal to f of 3. What is f of 3 in this case? F of 3 in this case would be 3 squared is 9 plus 6 times 3 is 18 minus 18. How many did you get? This is supposed to be believed. And I just made it up. I mean, I was not prepared with any standard question for this one. So now let's go back to the polynomial remainder theorem. It says that if you have a polynomial, if you divide that by x minus something, x minus a, then your remainder will be equal to f of a. And that becomes a magical formula that you can always apply. Let's say, if somebody says, let's pick up something that is known to us. But before I keep running around, is everybody with me so far? Is this understandable, digestible, followable also? Are you able to follow me? Smarni, I know this is your first class, so are you able to follow what I'm saying?
Yeah.
Yeah? Okay, because these kids, they have heard me so many days, so many times, that I'm assuming that they have probably learned a good or bad thing about my style of teaching. But yeah, this is a first class, so I'm just trying to make sure that you are with me as well. Now, let's pick up another one. Let's say I have x squared minus 4, okay? And if I divide that by x minus 2, this is a polynomial. I'm trying to divide that by x minus 2. And the polynomial remainder theorem says that my remainder would be, if I divide this by this, my remainder would be f of 2. Now here in this case we know that it's x squared minus 4 is nothing but x squared minus 2 squared. If I divide that by x minus 2, it becomes x plus 2 into x minus 2 by x minus 2. These two gets knocked off. This is my remainder. Yeah? Why I'm doing it that way? Why I'm actually doing it this way? I should not do it. So this says that if I have a polynomial, I'm dividing this by this, my remainder would be equal to f of 2. Let's figure it out. Same way. Let me not change the approach. Okay? X squared minus 4. I'm trying to divide that by x minus 2. So first thing I have to do is multiply this by with x. X becomes my first factor, and that gives me x squared minus 2x. Okay? So these two gets knocked off, then what I'm left with is 2x minus 4. Yeah? Now we know that I can do it x minus 2. So I can do it x. If I multiply this by 2, then I get 2x minus 4. So multiply this by 2, I get 2x minus 4. This becomes minus, this becomes plus. Did I get a remainder? Nothing. I got a 0 remainder. I got a 0 remainder. That means if I go back to the polynomial theorem, polynomial remainder theorem, it says if I'm dividing this whole thing by this, my remainder has to be f of 2. Is my f of 2 0? Let's put the value here. We saw that f of 2 is 4, 2 squared minus 4, which is nothing but 0. So this applies. Yeah. So what we are seeing here is that the polynomial remainder theorem works like a magic wand for us. You have any polynomial. I mean, tomorrow if somebody says, imagine in SAT exam, you are given a question, okay, saying, I have a polynomial f of x which equals x to the power 18 minus x to the power 24 plus x to the power 5 minus x to the power 17 plus x to the power 8 plus 17. This is a polynomial. Somebody is just playing with your emotions, okay? And if I divide that by x minus 3, find out what will be the remainder. Just by looking at this question, you will get scared big time. Yeah? But then, if you recall the polynomial remainder theorem, it says, okay, fine. If I have any polynomial, regardless of the power, if I am trying to divide that by this, that means my remainder would be nothing but f of 3. Now put the value of 3 in place of x. Use your calculator because I am sure you would not want to do 3 to the power 18 by yourself. That will take your entire city exam time. Put the value of x in this equation, find out the value, and you will say, okay, based on the calculation, what is my remainder? Without doing this whole complicated demonic problem to deal with. Yeah? And this, we have seen it working for a very simple polynomial, we have seen it working for a regular size 2-degree polynomial. If you want to try it for something a little more complicated, something which is in between, not like power of 18 and 24. Let's say if you have a polynomial y equal to f of x equal to x to the power 4 minus 3x cubed plus 16x squared minus 8, and you divide that by x plus 4, okay? What will be the remainder from this? So what I want you guys to do is, first try dividing this polynomial by x plus 4, that is the first thing, because you have to get your hands dirty like your teacher, okay? Do the division and then also find out the remainder using the polynomial remainder theorem. I'll give you guys probably 5 minutes, yeah.
Wait, so right now it's x plus 4, so would it be f of negative 4?
Yeah,
That would be it?
yeah. So see, this is simple. The equation says it's x minus a. Now, if it's given as x plus 4, that means your a value is nothing but minus 4. So do you guys want to try doing the division of this polynomial? Get your hands a little dirty. You can wash it off after the class, that's okay. And then find out what will be the remainder after dividing this polynomial. Is everybody with me? Sarah, Prisha, Rehan, Smrni, Snarka? Okay, Prisha, yeah, okay. Alright. So try solving it. Let's see how much fun it is. Okay, is anybody ready? Yes, Chris.
Sir, I got like a very big answer. I don't know if it's correct or not. But I'll just say it. I got x cubed
Okay.
minus 7x squared
Okay.
plus 44x
Okay.
minus 176
Okay.
plus 626 over x plus 4.
Okay. Anybody else? And did you find what the remainder would be? And did you verify that with the polynomial remainder theorem? So Chris, here's a clue. This is a remainder. This is what you could not divide. I mean, if this answer is correct, this is what your remainder was, right? And you can verify this remainder applying the polynomial remainder theorem. While everybody is trying to solve it, check if f of 4 gives you this value. If it does, then you are close to being right.
Okay, I'll check.
Yeah. Smani, is it looking okay? Is it looking little overwhelming to begin with?
A little overwhelming, but I'm pretty sure I'll catch up.
Yeah. No, you will be able to. I mean, see, when I put the question on the board, right, it will look little tricky, but when you follow those baby steps, right, every problem can be solved with the baby steps, right? So when you apply the baby steps, you will see that it's not as difficult as it looks, okay? And when I'm solving it, I always make sure that I follow the baby steps only, okay? Because simple things are much more fun than the complex things that we come across. Sarah, Neil, are you able to try better? Yes, Vishal.
I got the remainder of 696.
You got the remainder 696. Then you probably have a buddy in the classroom. Because Chris also got this answer. Plus 696 by x plus 4. Meaning this is the thing that he was not able to divide. Yes, Chris.
So I had a question. In the polynomial remainder theorem, did you ask me to plug in 4 or negative 4?
You will look for negative 4 because yes, your value is x plus 4, right? And the polynomial remainder theorem says that it has to be divided by x minus a, and then the remainder becomes f of a. Since it is plus, so that means your a value is negative 4.
Yeah, I plugged in and I also got 696.
Yeah, so because when Vishal also gave the answer saying his remainder is 696, then my confidence level went little up with your answer. That probably you guys are doing the same way. When two people do it, chances of both being right is more. I mean, it's not something that I can write in stone, but yeah, I mean, likelihood is more. Okay. Anybody else? Prisha, Deep, Dhanushri, Sarah.
I'm almost done, sir.
Almost done. Okay. Okay, 696. Okay. Then you guys are becoming good friends. Everybody is getting same answer. Likelihood is you guys are doing it right.
I also got 696.
So you guys are making me redundant as a teacher. Because everybody got the same answer. But then let's try doing it, okay? Just to make sure that at least I'm not wrong as a teacher then, right? So we are trying to divide this by x by 4. Same baby steps. x4 minus 3x cubed plus 16x squared minus 8. So I'm trying to divide that by x plus 4. First thing is I have to get rid of this one, and the only way I can do it by multiplying this by x cubed. So my first factor would be x cubed. So multiply this by x cubed. And see, this becomes x4 minus, plus 4x cubed. Minus, this becomes minus, these two knocked off. This becomes minus 4 plus 3, 7x cubed. Now this guy comes down, 16x. Plus 16x squared comes down. Now, obviously, to get rid of this guy, you need to multiply this by minus 7x squared. Minus 7x squared, when you multiply, this becomes minus 7x cubed. So let's multiply this by minus 7x squared. And again, always you have to focus on the first term, okay? Because that is how you are knocking off the powers one by one. So this becomes, when you do this, this becomes minus this becomes minus 7x cubed, and then minus 7x squared plus times 4 becomes minus 7 4 are 28 x squared. This becomes plus, this becomes plus. These two knocked off. This becomes 16 plus 28. This is 44 x squared. And then you bring this guy down. Now, the next thing you have to do is obviously get to 44x squared. And the only way you can do it by multiplying x plus 4 is multiply this by 44x. So if you multiply this by 44x, you get 44x squared plus 44 times 4, 176. 176 x. Yeah. Then this becomes minus, these two knocked off. Then you are left with minus 176x and then minus 8. So other thing that you have to do is, to get minus 176x, you have to multiply this by minus 176. Then you get this as minus 176x, and then this becomes minus 4 6 are 24, 4 7 are 28 plus 2 30, 4 1 are 4 plus 3 7. Yeah, and then this becomes plus, this becomes plus. These two gone. Minus 704, plus 704 minus 8. This becomes 696. So this is a remainder, and you can as well verify that, as I was telling Chris, right? So since you have finished it already, this is a remainder which you could not divide further. What did I do? X cubed, and then minus 7x squared plus 44, and then minus 176, right? 44x, sorry. Yeah. So this was my answer and this was my remainder. So now I was saying that the polynomial remainder theorem says that if you are dividing this by x minus a, here we are dividing by x plus 4, that means here a is minus 4. The remainder would be f of minus 4. Now put that value here, minus 4 to the power 4, minus 3, minus 4 to the power 3, plus 16, minus 4 to the power 2, minus 8. Do your calculation, that should match with 696. I can do that. I'm just trying to save time for you guys. Yeah. If you want me to do it, I can do it, but I'm just leaving it. But whatever we have done so far, is that clear to everybody? In the simplest possible way. Dhanushri, Chris, Neil, Sarah, Prisha, Smrni, Rehan, everybody? Okay. Vishal, Sunarka? Okay. So, there are two key concepts that we learned, or in fact we learned only one concept, that is polynomial remainder theorem. And this polynomial remainder theorem is nothing but, it's like a magic wand for solving any problem when it comes to finding out the remainder from dividing a polynomial by another expression. Okay? I mean, I can become little more kind of, what do you call it? I can go with a more strict intent to trouble you guys, saying, okay, fine, I have a polynomial x to the power 8 minus 4x to the power 7 plus 18x cubed plus 8. Divide that by x squared minus 4. You can divide that as well. Same approach, you can divide. But the polynomial theorem doesn't apply for this case. We are always talking about polynomial theorem where we are trying to divide that by single power or more like an expression which is linear in nature, which is x to the power 1 and then a constant. So it's more like something which is going to represent a linear equation in the future state if you want to use that as y equal to whatever this is, right? So we are talking about dividing a polynomial with a linear function or linear expression, and then it helps you determine what your remainder would be. And these would become more like a trick question or an easy picking for you to get a quick score in your SAT exam. Okay. So these are two things that we wanted to cover today and which we have done so far. Now let me pause here for a minute and hear everybody from Deep, Chris, Smrni, Rehan, Sarah, Neil, everybody, Dhanushri. If you guys have any question with respect to what we have learned, anything that is having simplest of the doubt, please feel free to call it out so that as a teacher I would know whether I'm able to explain things okay to you guys or I'm just wasting your time. Any questions? No questions? Smrni, any question with her?
No, not really.
Not really. Deep, you have been very quiet today. Any questions with respect to whatever we have learned so far? No? Okay. So this is the generation of emojis. You guys don't say yes or no, thumbs down or thumbs up, conveys the message. Which is fine, not a problem. So I was kind of thinking of picking up another topic for today, but I don't want to do that. I just want you guys to use the next 10 minutes to solve two polynomial division problems, polynomial long division problems, so that more you try, more you become comfortable with this, and then I will let you guys go as soon as you are done. 2x cubed plus 4x squared minus 17x plus 84 to be divided by x minus 8, and I want you guys to solve one problem which is x to the power 6 minus 18x to the power 5 minus 12x cubed plus 18 by x squared plus 4. And again, it might look like I'm making your life difficult. It's not that way. I want you guys to apply simple division techniques that you guys have been knowing for ages now. Apply that, try solving it, tell me what your answer is and what your remainders are. And you would probably use your polynomial remainder theorem concept with this guy to revalidate your answer. That becomes your technique for checking if whatever you have done is right or not. So I would want you guys to spend next 10 minutes or maybe less to solve these problems and tell me how did you solve it, what answer you got, and was it easy to do. Now I'm assuming here you guys are okay trying this and everybody is giving it a shot. Sorry. Excuse me. And when you guys are ready, raise your hand so that I would know that there's something ready for discussion. Okay. Yes, Chris.
So I only got the first one as of now. For the first one, I got 2x squared plus 20x plus 143 plus 1228 over x minus 8.
Okay. Yes, Chris.
Yeah, I got the same thing.
Same thing, same name, same answer. Okay. Alright, let's see what everybody else in the class says. Smarni, Deep, Vishal, Dhanushri, Pisha. You also have the same answer, Dhanushri?
Yes, sir.
Okay. How about Sarah, Rehan, Neil, Sunarka?
I got the same thing as this.
That means this was an easy one. Let's try the second one. Whoever has finished the first one, I request you guys to jump onto the second one and tell me how does it look like. Yes, Prisha.
Oh, sir, I got the same answer as the current.
Okay, the first one. How about the second one?
I'm almost done with it.
Ah, okay. Yes, Chris.
Okay, this is a really long answer,
Hmm.
but I got x to the 5th
Okay.
minus 22x to the 4th
Okay.
plus 88x to the 3rd
Okay.
minus 364x to the 2nd
Okay.
minus 1456x
Okay.
plus 5824. And then remainder 23314.
23314.
Yeah.
Okay. So your answer would be yes, Prisha.
Sir, I got a long answer too, but I got a different answer.
Okay.
I got x to the 4th power
Okay.
minus 18x to the 3rd power
Sorry. Yeah.
minus 4x squared
Okay.
plus 60x plus 16
Okay.
plus negative 240x minus 82 over x squared plus 4.
So I literally scared everybody in the class by giving this problem, is it? So be it a long answer or a short answer, I would not want to worry about it. Let's for everybody's benefit, okay? So since you guys have given it a shot, it's a teacher's job also to make sure that he's working with you. So let's try solving this one first. This one was an easy one probably. 2x cubed plus 4x squared minus 17x plus 84. And we are trying to divide that guy by x minus 8. So obviously, to get 2x cubed, I have to multiply this by 2x squared. So when you multiply this by 2x squared, it becomes 2x cubed minus 2 8 is 16 x squared. So this is minus, this becomes plus, this is gone. This becomes 4x squared plus 16x squared, 20x squared. Then you bring one guy down from here, which is 17x. Now to knock out this guy, you have to multiply this by 20x. That is how you get 20x squared. So plus 20x. So this becomes 20x squared minus 20 times 8, 160x. These two gone, then you are left with, this is minus, this becomes plus. So this becomes 143x. And then you get 84 down. Now, simple thing is, you have to multiply this by 143. That is how you will get rid of this guy. So this becomes 143x plus 84 is what you had. And then this becomes 143x minus 143 into 8. 8 is 143 into 8. 8 is 24. 8 4 is 32 plus 2, 34. 8 1 is 8 plus 3, 11. And then this is minus, this becomes plus. This is gone. And then this becomes 4 plus 4, 8. 8 plus 4, 12. And then 1 plus 1, 2. 1, 2, 2, 8. So this is your remainder, 1, 2, 2, 8. Did I miss something or did you guys miss something? I did not hear 1, 2, 2, 8 from anybody. What is that? Here. No, I'm saying this is remainder that I got. Did I miss something here?
No, they do have one
Oh, 1, 2, 2, 8. Okay, okay, my bad. I'm getting old. Sorry about that. So we got 1, 2, 2, 8. So this is not minus 1, 2, 2, 8. It has to be plus 1, 2, 2, 8. Because this one we got as a plus. Okay? Yes, Chris.
So for that one I got plus. I got plus.
Oh, you got plus only. Okay. I had probably noted down minus 1, 2, 2, 8 for some of you. That's where I made a mistake. Okay? But this is what we are doing for the first one. Yeah, Prisha, you were saying something, Prisha? No? So, whatever I did, is that clear? Is that in line with what you guys were doing as well? Okay. Silence means it.
I needed to poop very urgently. I live here.
Yes, Prisha. Okay. Alright. So let's go to the next one. Again the same approach. We have x to the power 6 minus 18x to the power 5 minus 12x cubed plus 18. And we are trying to divide this guy by x square plus 4. Same thing to knock up this guy, you have to multiply it by x to the power 4. So my first one is x to the power 4. That becomes x to the power 6 plus 4x to the power 4. Anika, sit down. We have still 3 more minutes. We'll finish this class and then we'll start for you guys. So these two gone. This becomes minus 4x to the power 4, or let me write it the other way around. Minus 185. This is 18x to the power 5. 5 minus 4x4. Same thing you will do. You will pick up x cubed and then knock up this guy. Then you'll go to this guy. So that's how we'll continue. So I'm not doing that. I know it's a lengthy problem and it might take time, but approach remains the same. You keep on knocking off the highest power, then the next one, then the next one, then the next one, and see what it comes down to. Okay? Anything that we learned in the class today which was not sounding convincing, reasonable, understandable, digestible, bearable, let me know. Everything okay? Okay. So if there is no concern with your teacher or whatever we learned in the class, I will let you guys go, enjoy the rest of your evening, and see you guys tomorrow at the same time. Alright? Thank you everybody. Yeah. Alright. Bye bye. Bye bye. Bye bye. Bye bye.